Good day, everybody. For today's lesson, we'll have simple and general annuities. Let us define annuity. When you say annuity, this is a sequence of payments made at equal or fixed intervals or periods of time. Example, your rental payment. This is a fixed payment. Your monthly pensions, monthly payment for car loan, and educational plan. Now, let us talk about simple annuity first. When you say simple annuity, the payment interval is also the same as the interest period. So, if we have here the example, 50,000 pesos is deposited every year for 5 years at 8% per year, compounded annually. So, as you see, every year, this is the payment interval period. Okay? Yearly. And our compounding period is also yearly or annually. That is why this is simple annuity. So here, the given are 50,000, 8%, 5 years. Okay? So, as you see, 50,000 is deposited every year and it is compounded annually. The compounding period, which is compounded annually, is similar with the payment interval or deposited every year. So, let us add all the future values obtained from the previous step. So, at first, the principal amount is 50,000. And remember, if we are getting the compound interest, our formula is a present value times 1 plus interest raised to term. So here, after 1 year, in our second year, we have 50,000 times 1.08 raised to 1. So, unahin muna ang 1.08 raised to 1 times 50. And that is equal to 54,000. That is for the second year. What about for the third year? We'll have 1.08 raised to 2 first. Ito muna. Multiplied by 50,000. And we have 58,320. Next is after 4 years. So 1.08 raised to 3 times 50. And we'll have 62,985.60. And then after 5 years, 50,000 is also deposited. So we have 1.08 raised to 4 times 50. And you will get 68,024 and 45 hundredths. Now let us add all the future values from the first year until the 5th year. So we have here, if you add, our total is equal to 293,330.05. Next, what about general annuity? What's the difference of general annuity to simple annuity? So when you say general annuity, the length of payment interval is not the same as the length of interest compounding period. Meaning to say, compounding period is not coinciding with the payment interval period. Okay, let us have an example. So, monthly installment of a car, lot, or house with an interest rate that is compounded annually. So, as you see, our payment interval here is monthly. But, our compounded period is annually. So, they are different. monthly and annually. In our second example, we have paying a debt semi-annually when the interest is compounded monthly. So here, class, payment period is semi-annually, but the compounding period is monthly. They have difference. Okay? Next, let us have the formula. We have W equals 1 plus R over M raised to M all over P minus 1. And we have N is equal to P times T. Now let us have this F VOGA, or future value of original general annuity. So we have here, this refers to annuity times 1 plus W raised to N minus 1 all over W. And for the present value original general annuity, we have F VOGA is equal to annuity times 1 minus 1 plus W raised to negative N all over W. Now let us have an example. Solve for the future and present value of general annuity of a payment of 2,000 every month to be compounded 6% semi-annually for 5 years. So as you see, class, this is an example of general annuity because our payment period is different from the compounding period. Our payment period is every month, but the compounding period is semi-annually. Now let us have the given. A, or annuity, is equal to 2,000. P is equal to 12. How do you get 12? Remember, when you say every month, there are 12 months in a year. That's why we have here 12. And our rate expressed in decimal is 0.06. Our M is equal to 2. How do you get 2? So it is said here that our compounding period is semi-annually. So you will just divide 1 whole by 2 because that is semi-annually. And next we have the term, which is equal to 5 years. Now let us find first the W. 1 plus R all over M raised to M raised all over P minus 1. Just substitute. Our rate is 0.06. Our M is equal to 2. Our P is equal to 12. So you have here 0.06 divided by 2 is equal to 0.03. And how do you get 0.16? You will just divide 2 by 12. That's why we have 0.16. Now we have 1.03 raised to 1 at 0.16 minus 1. So we have 1.0047 minus 1. And that is our W is equal to 0.0047. Now let us have the N. When you say N, we just multiply the period times the term. So 12, that is our P, times 5. And that is equal to 60. Next, let us find out the F VOGA, or the future value of general annuity. So you have this formula. First, you will just substitute. Our W is equal to 0.0047 and our N is equal to 60. So you have 1 plus 0.0047 is equal to 1.0047 raised to 60. Then we have 1.3249. So dito galing yan. Minus 1 all over 0047. Then we have 1.3949 minus 1 is 0.3249 divided by 0.0047. And we'll have 2,000 times 69.1227. Therefore, our F boga is correct. So what we have 138,255.4. That is the future value of the general annuity. Now let us have the F voga. So this is the formula. Just substitute. So our W here is equal to 0.0047 and our N is 60 all over 0.0047. Now we'll have 1 plus 0.0047 raised to negative 60 is 0.7548. So just subtract this one to number 1 and you will have 0.2452 all over 0.0047. Just multiply 2,000 times 52.1702. Ito po ay galing dito, quotient nila. Therefore, our answer is 104,340.